Hello guys, welcome back to our channel. If you are new here, please hit the subscribe button, share and like. And if you are a returning subscriber, welcome back. So today we're going to be discussing vertical projectile motion. In vertical projectile motion, we deal with objects that fall under the influence of gravity and only vertically. Projectile is the object that falls under the influence of gravity, only accelerate with constant acceleration, which is g, which is equal to 9.8. So there's one thing I'd like you to take note of is that our gravitational acceleration will always be negative 9.8. Reason being, our force of gravity always acts downwards. It doesn't matter if the object is going up or down. Now here is an illustration of what I've just said. So I have things that I would like you to always remember when solving a projectile motion problem. I'll use this illustration to try and make things easier for you to understand. Let's say a ball is thrown upwards and returns to the same position. We will denote the velocity of the point it left from as v initial. As it moves up, it will reach a point where it stops, and the velocity of that point is v max, which is always 0. As it returns back and hits the ground, it will return back and hit the ground with the same velocity it left with, but in different direction, meaning that our v initial will be equal to v final, and the time it took to move from v initial to v max will be equal to the time it took to move from v max to v final. Here are the equations that we use to solve the vertical projectile motion, and which we will be using to solve the following problem. Now the problem goes as follows. We are given a hot air balloon which is moving at constant velocity, and question 3.1 says that is the hot air balloon in free fall? Choose from yes or no, give a reason for your answer. And the answer is no, because we were told that the balloon is moving at constant velocity, meaning that force of gravity is not the only force acting on the balloon. And then right before question 3.2, we were given this statement: when the balloon is 200 meters above the ground, a small stone A is dropped from the balloon. See the diagram above. Another stone B is dropped 5 seconds later from the balloon while the balloon is still moving upwards at constant velocity. Stone A strikes the ground at the speed of 62,68 meters per second. Ignore air resistance. Now, question 3.2.1 says that calculate the speed of the hot air balloon. We will calculate this speed using one of the formulas from the previous slide. Now note this: when an object is thrown from a moving object, it can be a car or a balloon, its initial velocity is the same as the velocity of the moving object. Before calculating, we have to choose a direction, and in this case we chose upwards as positive. And then we will choose a formula which is suitable for this case, which is Vf squared is equal to Vi squared plus 2g delta x, and then we make Vi as the subject of the formula, and then we substitute, and then we get our answer, which is plus minus 2.96 meters per second. And then we chose the positive answer because the balloon is moving upwards. And then question 3.2.2 says that calculate the time it takes the stone A to strike the ground. And then also in this question we'll choose one of the formulas from that previous slide. And then the formula that we've chosen is Vf is equal to Vi plus g times 3. And then we'll make our t the subject of the formula, and then we substitute. After substitution, we'll get our answer, which is equal to 6.7 seconds. Question 3.2.3 says that calculate the distance between the hot air balloon and stone B at the instant when stone A strikes the ground. Now remember that it is given that stone B is dropped 5 seconds later after stone A was dropped. If it took stone A 6.7 seconds to hit the ground, it means that at that point stone B moved for 1.7 seconds. And then we'll calculate the distance for stone B using the formula. Distance is equal to V initial times time plus half gt squared. And then we'll substitute our values, and then we'll get our final answer, which is equal to negative 9.129 meters. After that, we'll calculate the distance for the balloon. Remember that the balloon was moving, so it also moved for 1.7 seconds. So we'll use the time to calculate the distance that it moved. And then we'll substitute into our formula. Our gravitational acceleration in this case is 0 because the balloon was moving at constant velocity. And then our answer is 5.066 meters. And then to get the final answer, we will add both the distance of the balloon and the distance of stone B, which equate to 14.195 meters. This will be the end of our video for now. Till we meet next time. Thank you so much for watching. Bye.